A very happy good evening to all of you. We're looking here at a conceptual exercise. We're showing and proving the case. I wouldn't use the word proof formally. We're verifying the case that this side is equal to that side. For a function which is an even function, we have this integral set up. We know this to be a case. It serves as a good shortcut for all of us. Minus a to a f of x dx, where this function is even, is similar and equal to 2 multiplied by the shorter interval from 0 to a, f of x dx. How can you show this to be the case? If you had an even function such as cosine x from minus pi over 2 to pi over 2, if you did the area determination from this entire interval, or you did it from 0 to pi over 2 and you multiplied by 2, in both instances they're equal. If you do it for the longer interval, you know when you do pi over 2 to minus pi over 2 cosine x dx, you have the antiderivative sine x come, and then you're doing pi over 2 minus pi over 2, you'll have a 1 minus minus 1, which is a 2. When you do it for the smaller, shorter interval, you're doing 2 and then 0 pi over 2 cosine x dx. You just have this sine x coming here with a pi over 2 and a 0. In this instance, you have a 2 times 1 and you get a 2. But in both instances, the area is the good and area is the same. So we know, practically speaking, this property is legitimate. We just have to show you why it is. How can we proceed with this verification procedure? How about we just start right here? If you do the antiderivative of f of x, you know it's this. We can use capital letters to indicate the antiderivative of an integrand from a to 0. Then you'll do 2, you'll have f of a minus f of 0. We won't assume f of 0 is a 0 because they're even functions for which putting a 0 gives you a good number. Like cosine of 0 is equal to 1, it's not 0. When you open this up, you have 2 f of a minus 2 f of 0. Now this right here is good. We have this and we'll put it aside. Now we evaluate this part right here. We evaluate it by splitting it up into two intervals with a shared limit. The shared limit is 0. Plus, see, 0 to a, minus a to 0, 0 to a, f of x dx. This here is easy. This here I want to convert by using this negative and flipping the interval limits. I have a minus a on the top, 0, f of x dx. I want to put this right here. There's nothing more I will do with this for now. Focusing right over here only. On this part right here, we know for even functions, f of x is equal to f of minus x. It's a property of an even function, which is why you have plus and minus x, two different x values having the same numerical number but different signs that give you the same y value. That test for even functions. Assume that u is equal to minus x because of u could equal to x, u could equal to minus x, they would have the same output. Then du is equal to minus dx, dx is equal to minus du. Your limits will change for that specific integral here. u1 will stay as a 0. Everything with regards to this, u2 will be a minus minus a, which will be a positive a. When you bring that in, you have this, you have 0a, you'll have f of u, and then you have a minus du. But I'm not bringing that minus du, I'm cancelling it out with that. That minus and this existing minus became a positive. Then I have everything else here which I want to bring back, and I want to erase all of this. I don't need it anymore. I have this a0 f of x dx. Literally, if you want, you can stop right over here and your verification procedure is good. I'm erasing this positive because no sign means it's positive. You can literally stop right here and say this is equal to that, because if you focus right over here, you're doubling something which is the same as you having split them up into their individual parts, and the parts were identical to each other, which is why you could double them up, and you can see exactly what I'm talking about. This plus this is equal to that, which is equal to that. But if for satisfaction purposes we don't want to do this logical shortcut, let's do this. We'll do the antiderivative placement with the definite integration. Capitals again, f of a minus f of 0 plus right here f of a minus f of 0. Combine the like terms. We have 2 f of a, and then we have 2 minus 2 f of 0, which very well mimics exactly what you have right there. So this is true, that's true, it's equal to each other, and we're good. This even function property of integrals, this minus a to a is the same thing as 2 times 0 to a. Remember again, you could have stopped right here at this point, and it is very well equal to this point right here because of the doubling of intervals. This right here is the doubling of intervals. F of u is equal to f of x. It's the same. And with that, I thank you for watching this video. If there are any questions or comments, leave them in the box. I will get back to you very quickly. Thank you. Have a nice day.